Okay, today we're going to do vector subtraction, and we're going to realize that vector subtraction can be considered the same as vector addition. So we're going to cheat a little bit. We have a minus b. We have the two vectors a minus b. There's an angle between them of 60 degrees. But instead of doing subtraction, I'm going to cheat and say that this is the same as vector a plus negative b. We know that that means the same thing. But what that allows us to do is change vector subtraction into a vector addition problem. So let's do our new vector diagram. So we're going to start by getting a, which I'm just going to trace over here to make sure I have the same length. And then I'll grab it and bring it over here. And that's vector A. And now I'm going to add vector B. But I'm actually going to add negative b, which means it's the exact same length and magnitude, but in the opposite direction. So when I go off to grab it, I'll put it at the end of A, and I'm adding negative b. And the result then will be a new vector that'll go from the start of A to B. And I actually want that to be red. So I'll just change it to red so it looks different. Yeah, we've got a triangle set up here, and we just have to solve the magnitude of the red vector. So I'm going to call that x, and we'll use the cosine law to solve for this, just like we did yesterday. So in this case, it's going to be x squared equals, let's get some numbers on here. A was 10. B was 15, and you'll notice it's still positive 15 because it's a magnitude. The negative just means its direction. So it's going to be x squared equals 10 squared plus 15 squared minus 2 times 10 times 15 cos something is the angle between them. Now in this case, the angle between them is right here. So how do I figure out what that angle is? Well, let's just extend this vector off in that direction and this vector off in this direction. And notice that that angle right there is 60 degrees, just like it is in the picture right here. And if that angle is 60 degrees, then the angle inside has to be 60 degrees as well. So it turns out that the angle between is 60 degrees. So now we go off and solve for this. Do your math, and I'll let you punch that in your calculator, give you a second or two. And hopefully you'll get an answer of 13.2 units. We don't have any actual units in this one, so we'll just say it's 13.2. So next, remember vectors is not just a magnitude, it's a magnitude and direction. So we have to give it some direction. And what we're going to do is we're going to refer to our direction relative to the first vector. And there's no rule that says it has to be relative to the first vector. I just do it relative to the first vector because it makes sense to me. It's where it's in the beginning. So I'm going to find off this theta right here at the beginning of this measurement. So to find theta, just like yesterday, we'll use the sine law. And so this is going to be sine theta over its opposite side, which in this case is 15, equals, now we need to pair up the ones we know, and we have these two known. So we've got the x side and the 60, so it'll be sine 60 degrees over x, and we just solved x. And we're not going to put in 13.2, we're going to put in the most precise decimal that we have, just to be accurate. Solve for this, the 15 is going to come up, and we'll have sine theta equals 15 sine 60 over 13.2. Punch that in your calculator, inverse sine, and you should end up with 79.1 degrees. Give you a second to verify that that's the answer that you got as well. So now to answer the question, we were asked to find a new vector, which is a minus b. And a minus b then ends up being this red line. And a minus b is 13.2 units at an angle of 79.1 degrees to vector A.